Hello, I am Wyatt Wilken,
I'm Joey Orlick.
I'm Joe Runte.
and we are the makers of the breakfast machine.
So, who here loves breakfast?
I love breakfast.
See, look at all these people who love breakfast. I know I love breakfast, but who here really has time to make breakfast in the morning?
I don't have any
No,
time.
you don't, Jack. Stop lying. But, so, I have the perfect machine for anybody who needs that. This right here, in case you're looking at it, it works perfectly 100% of the time. It's amazing. Our problem statement really was families all around want to have a balanced breakfast in the morning and they just don't have enough time to make it.
So the present solutions just are not that good. We have McDonald's. I mean, as we know, it's hit or miss. Sometimes it's great, sometimes it just is terrible. And also McDonald's is terrible for you. Another solution we have is the protein shake or the smoothie. Now, smoothies and protein shakes can taste good, but usually when they taste good, they are completely terrible for you. And when they're good for you, they taste awful. And last but not least, we have the sad breakfast sandwich over there that you warm up in the microwave. Those are just not good, and they just, look at that, it's just not appetizing.
All right, so the solution we came up with was a machine that gave you 3 different options. So you had waffles, bacon, and eggs, and you could choose any combination of them, and ideally, it would cook it for you. You would just have to select your combination and then press on it to start it cooking. And we also would have it keep the ingredients cold overnight, so you could just leave them in there and just flip the switch when you wake up so it's ready.
So we did a lot of survey and research for this project, so first, do you have time to eat breakfast? A lot of people say yes. I don't believe that. I think it's skewed results. I think it's one of the previous horrible things that people are eating for breakfast, not one of an awesome homemade meal that this machine can make you. And see, if people had time to eat breakfast, they would. 81.5% of people. And we were asking, what's their favorite meal? That's just kind of telling us what we wanted to make. It helped us choose what people wanted and what we would make available.
So the machine you see here is actually the second of our designs. Our first design had so many movements. And the movements were that you had like an arm come out, it would flip, it would rotate, and there was a bunch of things moving up and down. And more movement meant more air and more spots for it to not work. Another thing that wasn't great for our first design was it was working against gravity. If you look right here, we have our popcorn machine or the egg maker sitting on top of the machine. This is an issue because we are working, again, against gravity to get up to the top and to cook it. Also, there were just too many components, too many things that we had to try and figure out how to move at the right time, how to make it go into the spots we wanted it to, and how just to make it work. Last but not least, it was too expensive. We had 3 griddles, arm to dispense stuff, and a popcorn machine just to try and get the same thing to work. And for our $200 budget that we had to try and use, it just wasn't feasible.
All right, the first innovation that we had was we originally wanted to make pancakes, eggs, and bacon, but then we decided to go to waffles.
Or pancakes with dabs.
Eggs and bacon. The way we were gonna make the pancakes was gonna have two griddles and sandwich the pancake to cook it. But now with the waffles, we can just use the waffle machine. It's one thing we had to buy, and it would cook it on both sides. It would be cheaper, and it would be less complex for us to figure out.
Our second innovation that we made was we went from Tupperware containers, we were thinking of using that, to our pressurized PVC containers that you can see right there. They kind of malfunctioned outside a little bit. We don't care about that right now.
We don't talk about that.
But see, the Tupperware was less sanitary, it was less reliable, and with the pressurized tubes, it disperses it. When it's the correct pressure, it disperses it correctly and the amount that we want.
Another things that so I have a question for you guys. Who here would want an egg frisbee? Anybody? I don't see any hands up. So our original design was just to cook the eggs in a griddle and not have it scrambled. Then we had the great idea to use a popcorn machine as our scrambled egg device. The popcorn machine would allow the eggs to be light and fluffy and be scrambled all automated without us having to do any work. This also made it so there wasn't anything stuck to the bottom of the pan because it would scrape the bottom of the pan and make sure there wasn't any burning of the eggs.
We also attached it to the drawer with pegs so that it was easily removable for cleaning, which came very helpfully. The next innovation we had was going from our original design to our final design. Obviously, the original one had way too many expensive components, and in the end, it really just, there was no way to figure it out within a year to work with that. So we went to this. It is cheaper, it's simpler, and it works sometimes.
So in our original design, we had this bacon arm thing. It would you would drape the bacon over, it would go out, flip. That is a lot of movement. What we changed it to was a bacon conveyor belt. So you just put the bacon on, and it'll just drop them off, and it'll drop 3, I think is what we wanted around there for a good meal. And it's a lot more simple. It's just better all around, does not give us as many headaches, and it just works so much better with our project.
So if anybody here has ever programmed, you know it is a pain to learn and to work with, as our classmates over there probably all know. So the first thing we had to learn with our programming, which is Arduino and that runs off of C++, was the basic functions of the programming. So we had to learn how to make everything run. The next thing we wanted to learn was the emergency off switch, or in our case of programming language, an interrupt button. This would allow us to, any point in the time of the program, flip the switch and turn it off and stop cooking and stop whatever problem we had. Second, we had to try and learn how to debounce things. In the end, we didn't have to use this, but when there was a button for our program, debounce would allow us to make sure that there's only one button push and it wouldn't read any noise or any issues within the button, within the push. In the end, we used a switch, so the debounce wasn't really used. The next thing was the functions. The functions we used to actually cook our ingredients. This way, we only had to write down the code once, and then you would then put it into your case statements, which is our final thing, which then would decide what you wanted to do. Now, the case statements are basically the main parts of our things. So on the back of our machine, we have the control panel, and you would select what combinations you want or what case you would want in the program, and it would then run the functions and cook your breakfast for you.
All right, so for the building, the first thing we had to build obviously was the body. So we went to Home Depot and we got a big sheet of melamine coated plywood and cut it up and designed it, cut it up, and created the body with a separating shelf and the sliding drawer. The next part was the piston to move the drawer in and out. We made that using PVC for the body. We used a solenoid valve to regulate the air pressure going in and out so that it would move in and out. And then we had a Christmas tree adapter to make sure that it fit in with everything else. The next things that we had were the cooking appliances. We had the griddle, the waffle maker, and the popcorn machine that we used to make the eggs. For the bacon conveyor belt, we made the body using wood, and then the little things that the belt spins around on, we made using PVC, and the belt was obviously just fabric that we found that was food safe enough to use. And then to move it, we used a stepper motor with programming to make it move at the right intervals. The cooling, we got a mini fridge system, which we'll explain later, and put it inside to keep everything cold overnight. And then, last but not least, the ingredient containers, our favorite part, we made using PVC and quick disconnects to pressurize and depressurize it, and then solenoid valves to regulate when the ingredients are going in and not.
So our electrical and wiring situation. So our Arduino does not give off nearly enough power for this beast. We needed 24 volts for almost everything that's being used. The Arduino gives off 5 volts, so our obvious solution was use a relay. Our relay connects from a different power source. It just acts as like a better power source while the Arduino still turns it on and off. But the relays don't have a big enough power jump for everything we needed. So our obvious solution was to use 2 relays, and it works fine, it works good, everything's working. And so wiring, it goes from our power supply, which can have like 220 volts, but we set it to only 24 so it doesn't go over circuit everything. So we use that connects to the relays, and the relays connect to everything like the solenoid valves that turn everything on and off, so we can just turn everything off using the Arduino.
So the movement was also an issue for us. The designs that were pre-built for us on Cerebral City and the linear actuators were very expensive, and in the grand scheme of things, were just too much of a budget that we could use. So we decided to make a pneumatic piston out of PVC. As you see down here, the layout for a pneumatic piston, and under the platform, the piston will sit there. There is 2 quick air connects on our piston right there and one in the front. And if there's air pressure put to the one in the back, it will push the PVC piston out, and if there's pressure put to the front, there's PVC pressure to push it back. Now, the PVC has an end cap and some adapters in there that are sandwiched together, an O-ring, which then will create our seal for the back. Now the front took some CNC of some different PVC parts and some different O-rings to try and make sure it's sealed, and didn't have any blow-by out front. And in the end, and in the beginning, we decided we were going to try and make it even cheaper, or we didn't think of using PVC, and we were going to try and 3D print the parts. We soon found out that the 3D printed piston didn't have a smooth bore, so we had air leak by, and did not work for our movement section of the project. So in the end, we used PVC that we could find at our local Menards or Home Depot.
All right, now the cooling system. So we originally, for the cooling system, were thinking we were just gonna do a box with ice in it and then insulate the inside of it, because it was the cheapest idea at the time, and we were running kind of low on budget. But then we started to look into using a mini fridge cooling system. So we looked on Amazon and Walmart and stuff like that, and we couldn't find something big enough that was also cheap enough to fit our budget. So we actually decided to have Mr. Rader help us out and send an email out to all the teachers around here, seeing if anyone had an old mini fridge that they weren't using anymore that they wouldn't mind donating to us for the project. And we were able to get one. So we spent a good couple of hours pulling the actual system out of the mini fridge in order to cool it correctly, and then we put it in.
So now we have a video of the eggs cooking. It takes a little bit to get to it, but Joe's just showing off all the parts right there. That is the valve that the eggs come out of. That's the egg cooker. It's not on right now, as he's saying, by touching it. But it's gonna turn on, and it goes from that, it's pressurized, the tube, and see, he's pointing at it now. And then that's our control panel. He's gonna point at it soon. There we go. And the control panel is you just flick the eggs, and then you'll just turn it on, or you'll flick whichever combination you want, and it'll do it. And so this always preheats for 15 seconds beforehand. See, showing, spinning, it's on now. So they get hot enough so it doesn't take as long to cook it. You can just have them all ready for cooking. And now we just wait, see it shoots out. That's the piston right there underneath that caused that. And now the eggs are spilling out, and they're gonna be cooked. It's spinning, it's cooking.
The video got cut into 2 parts because I was a little sweaty when we were doing this and accidentally paused the video. So it's basically the second half is just showing it finishing cooking.
I don't know if you need to see it. It's just gonna finish cooking. Look, now this video is playing.
I was tired.
He's spinning around. See, it's cooking the eggs. It's getting broken up. I don't know if you want to watch all the way, but I'm just gonna go to the next slide.
And some issues with the egg cooking, if some of you guys watched, we noticed that we possibly had an issue with the powering, or somehow there was not enough power going to the eggs or the egg cooker, so we didn't think it got us hot during our presentations out in the commons. So we were thinking that's why the timing was off. If I would be paying attention. I'm going to explain the bacon to you guys. So the bacon is, again, on the conveyor belt, which is ran by some stepper motors. If you select bacon right now, it's gonna go now. So now we selected bacon, and we are now letting it preheat just like every other selection we have. And once it's done preheating, the stepper motors will rotate the conveyor belt and drop the bacon into the griddle, and the griddle will then dispense out into the area, so it's not sitting under the machine cooking in a few seconds here. And this will allow it to cook without any loss.
For this one, the piston didn't go out, but it was good enough for the video. Also, for the bacon, we used pre-cooked bacon because we don't want, it's easier to just warm up pre-cooked bacon. I don't know if you guys would care too much about, like if you wanted to buy this amazing product from us, like any investors out there, the bacon is just, unless, like, I don't know how you would get fully cooked bacon, like raw bacon, but if you want, you could always try. We could always look at that.
All right, now we got the waffle. So eventually, I'm gonna show you that, yeah, that's the tube where the stuff goes to. That's the container that it's in. And then we got the valve that controls it going through and out. That's the control panel. The buttons are waffle, bacon, egg, and then on and off at the top. That's the Arduino with the relay shield. Okay, it's starting now. So it's turned on. It'll preheat first, so that light shows that it's on, it's heating up. The eggs are gonna come out of that little elbow there into the pan. I moved the top of the, not eggs, waffle stuff. I moved the top just to show the video. It doesn't really matter because it's gonna close when the drawer goes out. So it goes out of there and then shuts off eventually. And then the drawer waits for it to make sure that it drips all the way, so there's nothing dripping when it goes out. And then it'll go out and it'll close and start cooking, like that. And then it cooks for a while. We'd be sitting here awkwardly for a little bit. It's cooking.
So again, some problems we ran into out there is the air pressure. We just could not figure it out. When we were sitting out in the shop, we were able to fine tune the air pressure and get it to fire everything just perfectly and make sure everything was running just right. And we were also able to make sure we got the right consistencies with all of our batters and our solutions. And when we brought it out into the showroom, we didn't have time to tweak it to make sure everything was running off the right pressure and the right powers.
Eventually, it's gonna go in and open up and show you guys the waffle that's been cooked.
This should be like a 2-minute long video, so I can't skip it. I would just skip to the end.
No, they gotta see the waffle. Get comfortable. Also, for the batter, we had to make it liquidy so that it wouldn't clog the solenoid valve, because if it was too thick, the chunks could get caught in the filter and it would not go out. That's the air hose, as I'm gesturing to, I guess. We got the cord. I think I point out next that plugs in the waffle maker. Yeah, that's just the cord that was in the way, so we threw that out of there. And then the green cord's attached to the waffle maker. That's what's plugged into in the back of this, the relay for the power. There we go, and that's the waffle.
Any questions?
I love the idea. I would have voted for breakfast made for me, so I disagree with the survey results as well. However, I do wonder then, do you have, like, is the concept that I would have to in the morning, like if I wanted it made for me in the morning, I would have to put the ingredients in there? Are there enough ingredients to like just press the button when I wake up and it's going?
Our initial like thought process would be, since we have the cooling system in there, you would just make it like the night before or something, or like whenever you have time the day before, and you just leave it in there, and then in the morning you just flip it on so that you can get ready for your day while it is cooking all your meal for you.
And did you think about the part about who's cleaning up the dishes?
We actually,
Really, just kidding.
I mean, to clean everything out, like for the containers and stuff, we have cleaned it out using soapy water, and you just flush it out by turning on all combinations and starting it so it'll go through and shoot everything out like it would in the normal thing, just to clean everything out, and then everything else is removable, just cleaned in a sink by your woman or man.
Any other questions?
A couple of them.
Lots of questions up here. My question is, have you successfully eaten breakfast from the machine?
It wasn't at breakfast time, but I have successfully eaten every single part of a meal from the machine.
All right, so I don't know what unknown location you worked on this at, a government facility, whatever it was. But what did you do in class? Like, I was in the room with you guys, but I never saw anything done.
We took care of a lot of the coding and stuff in there, and I mean that's what we'll save. We also had a lot of fun. They don't
Yeah,
even know that.
this was the first time we saw it working. All right, thanks guys. All right, survey time.